economy of scale, you know. But anyway, so there are a couple of points that I'd like to hit right at the beginning of class, although I suppose I will certainly be repeating myself once the rest of the class gets here. But there is a rather bulky download that we should just start now, you know, because we'll need it later on in class. It definitely, like, I just don't want it to hold the download time to hold us up, right? So our plan for today, we're going to be going through sort of polishing off some topics in the area of user validation. This is mostly conceptual work. I will show you a few useful and interesting functions. We'll talk about password hashing, that's probably the biggest takeaway. But then I'd like to skip through that as quickly as possible so that we can get to Laravel, because you've got a fifth assignment, or fifth or sixth? I think it's fifth, sixth, something. You've got an assignment that requires Laravel, so it would be good to cover it before the end of the semester. So let's see. Do we have 5 or 6?
We have 6. The last one is Laravel, but there's one before that.
Yes. Multi-page survey. Yes. What's the deadline on multi-page survey?
April 6th.
Okay, we should probably start by talking about that then, eh? Yeah, okay. Okay. We'll start off by talking about assignment 5, multi-page survey. So, multi-page survey is, well, you may have noticed that a lot of the assignments in this class have kind of been focused on the kind of web form and managing web form data. Of course, if you've ever filled out one of the rather extensive web forms that the government has on offer, particularly the government seems to like this, it is quite rare that all of that information will be on one page. There's kind of a good rule of thumb where you don't want to put too much on one web form page, because if somebody messes something up or the page breaks in some way, it minimizes the amount of data that the person loses, and they don't have to start right over from the beginning, right? So basically, yes. Human beings also only hold 7 to 12 items in short-term memory at once, and a multi-page survey can help reduce cognitive load and expectations on users. So, basically, we're going to be doing survey forms basically similarly to the previous couple of assignments, but this time, the last one was the table actually. So it's a bit like the assignment before that, but just like across multiple pages, managed on the server with sessions. So the first page should present a form and inputs that request the user enter first name, last name, and birthday. When the user clicks on the next button, the next page should load. So note, this content is not being dynamically popped in using JavaScript. We are actually loading the next page. We are entering a request for an additional HTML file. The second page should present a form and inputs that request the user enter their country, province, city, address, and phone number. When the user clicks on the next button, the next page should load. The third page presents a form that requests the user enter information about a healthcare related issue. When the user clicks on the next button, the next page should load. And then the fourth, more information about the healthcare related issue. You can see that those are somewhat vague. You should be thinking sort of in the same line as the web form from previously, you know, checkboxes for coughing, sneezing, and hacking, you know, how long have the symptoms persisted, all of that kind of stuff. But as you can see, it's not specified in the assignment, so you have some degree of flexibility for what actually you are presenting. So, the 5th page should present a summary of all of the information that was entered, i.e., what value was entered for each of the requested inputs. When the user clicks on a complete button, the final page should load. And the final page simply reads, "Thank you for completing the survey." So the trick with this, right? This is an assignment which requires you to use sessions, right? JavaScript variables do not persist between page loads. PHP variables do not persist between page loads. PHP sessions persist between page loads. So you are required to start a session with the user, store all of the information that you gather in the session. They should be sent to the server using either a GET or a POST. Although honestly, I think you should be able to do this without very much JavaScript at all. I'll reserve comment on that until we reach the end of the assignment description, but so far, you can do most of this with default HTML forms. I don't think you need JavaScript just yet. The focus on this one is definitely the server-side code. So, you should store the data that the user enters on the first 4 pages into the session array. When the user reaches the 5th page, you should then present all of this information stored in the session array. The next button for the first 4 pages should really just be a submit button for the form, and the form action should cause the next page to be requested. So far so good, so far no JavaScript. So the PHP script for page 2 should store the data entered on page 1 into the session array, and so on. Use Bootstrap or some other style that you prefer to style the application. Should look nice, should look professional. Your solution should work when I copy the unzipped contents into my own XAMPP htdocs folder. Submit your solutions file into a zip file called as5.zip. So, right, so, session storage, 20 marks. Session retrieval, 15 marks. Page forms with next and submit, 15 marks. 6 pages total, 15 marks. Summary and confirmation page, 15 marks. Professional styling, 20. So, this one shouldn't be too bad. You should be able to whip this one off reasonably quickly. Like fundamentally, it's not even asking you to do any validation, right? All it's asking you to do is to take data, send it to the PHP script, retrieve it, just tuck it away into the session. Then, when you're on the final page, pull it out again, and that's it.
Will you take validation into consideration with marks at all?
It's not in the rubric. So, if you want to, for practice, I encourage it. But if you're, let's just say a solution which achieves 100% on this is not required to have any validation. Okay? Sound good? Any questions? Fairly straightforward? Hopefully. Good. All right, so that's assignment 5. So, now that we've discussed assignment 5, I'd like to talk to you now about Laravel. So, you've been working with VMs a little bit in another class, as I understand it. Perhaps it would be good to get a few pointers. So towards the second half of our class today, we're going to be using a PHP framework called Laravel. Now, Laravel's setup and installation is complicated and difficult. All right? This is why a virtual machine is being provided to you, pre-configured, with everything you need to run Laravel. Now, in recent versions of Laravel, they have simplified the process considerably by creating what are called Docker containers. Have you guys heard of Docker before? So, this is kind of the direction that things are going at the moment. It is increasingly likely within your professional lives that you will be required to use Docker. So let's start with, do you know what a virtual machine is? What is a virtual machine?
Like an operating system running inside of your computer that doesn't necessarily have to be the operating system that is programmed to your machine.
Yes. So it's an operating system within your operating system, right? So to kind of give you a bit more of a feel for what you're doing, though, right? You guys have been taking an operating systems class, right? What are the different layers of the operating system?
You mean like hardware?
Hardware is one, yeah. Let's start with hardware. Hardware, of course, is the base layer of the operating system. It, of course, is extremely complicated within itself, but because we're software people, we don't have to care about hardware, right? What is the layer that sits on top of the hardware?
The operating system itself?
We're trying to pick apart the structure of the operating system. This is a component of the operating system. A very important component. One might say the central core of the operating system. The nugget, the little piece of grain inside of the middle of it, as if it were made of corn. What would you call it?
Kernel?
There we go. You have the kernel, which is actually named for that particular reason. So the kernel communicates with the hardware directly. Device drivers, standard library functions, other stuff too. The kernel is everything in your operating system that's written in a low-level language like C, basically. So, on top of the kernel, what is the layer that sits on top of the kernel? To continue our botanistic metaphor, if this would be the nut, what wraps the nut?
Thread?
Nope. You've got the nut meat in the middle, around that goes.
Husk.
Close. Almost, you're almost there. Clams have this too.
Shell?
There we go. The shell. So shells come in many different forms, and typically, in a modern operating system, you will actually have a few different shells running at the same time. Shell. But there will always only be one kernel. So, in a typical operating system, the graphical user interface which you are all using to interact, that's one of the shells. Because we're now thinking more in Linuxy kind of worlds and terms, when you have a command line interface like bash, that is a CLI shell. So shells come in two main varieties: graphical user interface and command line interface, right? And you can tell which one of them is like more in my heart. There we go. Command line interface shells are the best. So, okay. Within the shell, the thing that you run, or the thing that you run on top of the shell, is what you might call your user program. Also known as user mode programs, things like your office software, your browsing software, the programs that you run, Solitaire, Minesweeper, all of these things, those are user programs which are running on top of a shell. In the case of command line interface, you might be talking about, command line commands. Those are actually user mode programs. Things like cp, copy file, make directory, change directory, all of your standard Linux operations are user mode programs for a command line interface shell. Does this make sense so far? So far, so good? So now let's see what happens when we start virtualizing. So the point of virtualization is that we have the same hardware, right? But we have a new thing which allows us to run a different operating system, right? I'm going to do this in a different color. So at this point, embedded within the kernel, we have a new type of process which is called a hypervisor. The hypervisor is comprised of kernel processes with a few other things thrown on top. Now, hypervisor, you can think of that as being the back end of VirtualBox. VirtualBox will initially load as a user program, but what it does is it starts up a hypervisor. Now, within the hypervisor, you now have a kernel which is sandboxed away from the rest of the operating system. It cannot communicate except by very specific channels, right? So, within the hypervisor, you can run shells, you can run user programs. Does this make sense? So far, so good? Okay. So that is a virtual machine. Okay? The Laravel setup virtual machine, which you're all going to use, is one of these. It comes with all of the Laravel installation stuff already done. Now, that being said, like, the Laravel installation process is very tricky. It requires installing many, many libraries over a number of hours. You require specific versions of PHP. You require specific versions of other libraries, and you have to do a lot of manual installation. This is generally not how people like to do things. So, they within the last couple of years, they now prefer Laravel to be installed with a thing called a container using a program called Docker, which I'm actually in the process of updating some of the courses for the college stream to use Docker because it is the new business. Oh, and this is VirtualBox. So the way that a container differs here is essentially you still have the hardware, obviously. Oh, okay. Yeah, so you still have the hardware, right? And you still have the oh, I'm messing my layers up. Hardware, kernel, hypervisor. In this case, it's Docker. So I'd like to modify this diagram as well. Some kernel functions will exist inside of the hypervisor as well. A few. A lot of it is provided by the hypervisor, but it needs some kernel here as well. Like, the hypervisor itself is basically agnostic. It could be running a virtual machine of any type, Mac, Windows, Linux, any variety of Linux, more exotic operating systems as well. Those operating systems come with a kernel. It's not necessarily baked into the hypervisor, right? So the difference between this setup and this setup is that containers are ultra miniaturized individual VMs. They're like tiny little bite-sized VMs. That's what a container is. So you will have a kernel, a shell. Actually, a lot of the time they don't run in shell mode, and then you have a user program. Kernel, shell, user program. You have a bunch of these things going on simultaneously. I was looking into this before class, and the containerized version of Laravel, which uses Docker, I think it was 8 or 9 individual containers all running in parallel. So, like, the idea is you've kind of, like, fundamentally changed the orientation of what the VM is trying to do. Here, you are trying to simulate a general purpose operating system that, you would just install on a computer, right? You're installing a full operating system. Here, a container is only enough operating system to run one program. That's what the idea behind a container is. So it is, in theory, now possible to install Laravel on your own machines using Docker in a way that I certainly would not have recommended 2 years ago. That being said, if you have a Mac with an ARM processor, the Apple Silicon, I use a lab computer. They don't really like virtualization at all, unfortunately. So each one of these is a container. Right? So basically, the thing that the container makes easy is all of the ridiculous configuration stuff that Laravel used to require. These containers come pre-configured for whatever version of Laravel you pull. So there's a program called Docker Desktop that you need to install on your own computer if you want a native installation of Laravel. There are instructions on the Laravel website to install Laravel using Docker. If you want to attempt a native installation, that's what you would do. But if you can run virtual machines, then perhaps you should, because even, it's significant, it's much, much easier than it used to be, but, it's still a non-zero amount of time that you have to spend configuring things. Okay? Does that make sense? Okay, so let me show you where the virtual machine is then. There we go. So, in modules, you will find a category that you've probably skipped over and ignored until this point in time, Laravel installation. You will note there is a link, laravelsetup.ova. At this point in time, if all of you could please initiate that download. It's 6 gigabytes, so it's going to take some time. But we will need it for the rest of class, so please download that file.
We don't have access to it.
You don't have access to it. Okay. You got USB keys?
No.
No, I don't have my actual backpack with me.
All right. Well, it's not my file, so I don't have permission to modify the permissions. But maybe I could. Manage access? Can I manage access? Oh, maybe I can. People in Mohawk College of Applied Arts and Technology with the link can view. Are you guys logged in?
Yeah.
Not yet. You could just post the link in the announcements.
Well, it's the same link is the problem. Okay. Okay, people are gonna have to start giving me student numbers.
000793155.
There you go. All right, student number.
000949955.
Student number.
000943221.
There we go. Okay. Access requested. I don't know if Kevin's gonna have to see that and approve it. Try reloading the page. Still nothing? Okay, well, we may have to put a pin in that for now. Okay. Let me just shoot a quick email. How infuriating. Why wouldn't you folks be considered people with permissions in this institution? It's very strange. You should be.
It's the Laravel setup.obo link that we're trying to open.
Yeah. Pardon me. And just while I'm at it, okay, looks like 2 of you are on there. You 2. Did you guys, can you try the download link again?
Oh, it's working.
Oh, perfect. You must be getting the messages. All right. I'm just going to do that for everyone right now because might as well do it for everyone, right? I don't know, maybe if you didn't come to class then you don't get the right.
You just can't do the last assignment, so.
Yeah, not that much earmark, right? And no, you could do it, you just have to do the manual installation, that's all. There we go. Okay, you should have permission too now. Okay. There we go. Kevin for the save. You saved my class. Thank you, Kevin. Okay. So basically just start that downloading. I don't know how long it's going to take. The other thing is once it's downloaded, we need to unpack it in VirtualBox. So a couple of things about virtual machines, right? What you have just downloaded or are in the process of downloading is essentially an archive version of a sort of base virtual machine. As you modify files in it, first you need to extract it to like a proper folder. As you modify files in it, the VM will remember the changes you've made. If at any point you've goofed things up so monumentally that you have to like revert back to the archive, you can just re-extract the archive and you'll be at a fresh installation, right? However, any changes that, basically the position we're in right now is without some place to store this, and it's gonna get a little bigger once it gets extracted, right? If you don't have a place to store these 7-odd gigabytes of information, USB key, preferably an external hard drive, basically any changes you make, this class will be lost. So, maybe by tomorrow, but certainly before next week, if everybody could please have something to put a virtual machine on. This is not the last time you will need it in this program either. I'm introducing Laravel here, but I'm pretty sure, like, in a few semesters, not sure when precisely, but you're going to take a more thorough stab at frameworks and Laravel with Kevin at some point in the future, so you'll need this anyways. My recommendation is to buy an external hard drive, if you don't have one already. An external hard drive, like 1 terabyte is like the nominal size for a small one these days, and that will be plenty of space for this virtual machine, and a bunch of other stuff. You could do many virtual machines on one, but the whole, the thing you need to do is to unpack the VM into the drive. That way you always have your virtual machine with you unpacked, because it takes 5 to 10 minutes to pack and unpack these things, right? So that saves you that time if it's just sitting on drive unpacked. Certainly, it'll be slower if it's having to go through a USB. It's Linux. The fact that it's slower isn't as big a deal as you might think it is. But if your idea is a USB thumb drive, that thing is not going to be fast enough. To run an operating system, you really should have an external hard drive, and like a decent one. Kingston or Western Digital are good brands. AData is not, in my considered opinion. So does that make sense? So everybody will have memory with them when they come next week at least, preferably tomorrow, maybe. So let's get the thing unpacked then. Installed on the lab computers, not through Mohawk apps, but just as a native installation on the lab computers, you do have VirtualBox. Oracle VM VirtualBox. Please launch that software. There you have it. Now, you'll want to click Import. Find the file that you just downloaded. It's probably in Downloads. There it is, Laravel VM. Open her up. Next. Just go through all of the, just allow defaults on everything. It takes time. It depends on how much memory you have. Virtualization is a fairly memory intensive operation, so if with your with whatever laptop or desktop computer you're working with, if you are working with under 8 gigabytes of RAM, I would say it might be time to consider ordering a stick off of Amazon and giving yourself a boost. 8 gigs, an 8 gig stick on Amazon I think runs 30 or 40 bucks, although that was before tariffs, so who knows. But if you need, I highly recommend upgrading your memory. If you're under 16 gigs of memory, I would consider 16 gigs to be the bare minimum you should be on if you're going to be doing this type of work. Okay? Sorry I'm telling you to spend money, guys. It's unfortunately it's just kind of goes with the territory. Don't go to Canada Computers, they don't have any, I checked. Any questions about that so far? Mine has unpacked already, but I'm not sure if your lab computers are like significantly worse than the podium computer.
Mine's unpacked.
Yours unpacked? Okay. Alright, cool. Okay, so that was actually going to take longer than I thought it was, or it didn't take as long as I thought it was going to. But, so, let's see here. Still, I'm glad I did that first. So let's talk about user authentication, and then we shall dive into the world of Laravel. So, user authentication. What we generally mean when we're talking about user authentication is we are trying to take communication from one client and establish whether that one client is who they say they are. The sort of bread and butter of user authentication of the contemporary internet is the username password system. This has been the system that has been persistent since some of the early days of computing, and it will be around with us for some time into the future. Of course, people make, people kind of have been trying to get away from password systems because they notoriously have problems, as we saw in those YouTube videos which we watched over the last couple of weeks. Two-factor authentication is something that they've been trying to roll out, but if you'll notice, nobody is yet going with two-factor authentication as the only form of authentication. Fundamentally, the thing is still backed up by our good old friend username password, right? So, yes. So, there are 3 key steps to user authentication. You need to be able to log a user in, log a user out, and grant or deny access to a user. So, question. Does the user have access to the page they're trying to view? Not all users are privileged equally. A great example of this is Canvas. Because I am an instructor, I get to view all kinds of things on Canvas that you folks can't. Very important things too, like the grading system, right? When my speed grader application that lets me enter rubrics and that sort of thing is not something that you folks see at all. All you see is the final result that I make within that sub-application, right? So not all users are privileged equally, right? So if a user is trying to access a page that doesn't belong to them, we need some way of redirecting them. So, There are a couple of ways to solve this. This is kind of more of a vanilla PHP way of going about it, rather than like MVC architecture would have a slightly different way of handling this. But we often need to redirect users to another page. For example, any login attempt is attempting to load the equivalent of the dashboard page that we made in our example, right? We need the ability to redirect people away from pages they don't have permission to view. The way that you do that with it is using this function. Header, location, gets, and then whatever page you want to redirect them to, right? If you include this line, this works by setting this field inside of the HTTP header, right? So the header contains all kinds of useful information, the URL, what the packet method is, what the content type is, and if we set location, where the user should be redirected to. When the response is sent to the browser will make a request for login.php at the same root. So basically it's like, think of the communication this way, right? The client requests a page that it can't access. The browser says, no, go here. That gets sent back to the client. The client says, okay, give me that page. And then the browser sends them that page. That's what a redirect is. Now this is, of course, inherently less efficient with respect to bandwidth than simply giving them the page they should have seen. This is the sort of advantage that MVC architecture gives you, right? Using this, you cause 2 server accesses, right? Using MVC, you have 1 server access. It causes less network bandwidth, or network overhead. Important, we cannot have any HTML or other output before running the header function. So if this is going to be done, it needs to be done at the top of the file in PHP. Does this make sense? So far, so good? Good. Get out of here, you. So, I think we should already have a fairly good idea what a login is, as we've already implemented a login system. So what is a login? What are we doing with a login?
So like allowing the user to type in like a certain word or password to be allowed into like a document or something?
So let's examine things from the perspective of the server. What are we expecting from the client for a login attempt?
Like a certain like phrase or like numbers or keys?
So we need a password. What else do we need?
A username?
That's right. So we have a database. In that database, we're keeping track of valid username password combinations. If we receive a username and a password from the client, we then check those against the database, see if there are any matches. If there are no matches in the database, this is not a valid user. So we say, nope, login denied, try again, Sparky, right? If that entry does appear in the database and the username and password match some particular entry in the database, then we know that that is correct. We have a good login. If there's a good login, we use the session to indicate that the user has successfully logged in. Essentially, we have validated the session, right? You may remember me saying previously that when it comes to sessions, a lot of people might think that you want to establish the session when the user has successfully logged in, right? Because that kind of makes intuitive sense. But it makes a lot more programming sense to just have the session running by default, right? Because it costs you almost nothing to put a cookie on the client's computer, right? Just have the session running, and if the user logs in successfully while the session is running, put a little variable inside of the session that says, yeah, this is a validated session. You now have access to this, that, and the other, right? And then the server can use that to grant or deny access to pages and information. Does that make sense? So that's kind of the whole process. Yes. So when the user logs out, this usually triggers a redirect to a login page or a front page, something of that nature. I disagree with the slides here. Often what's done is not that the session key is removed. Like the cookie itself is not invalidated much of the time, but the session variable, which was telling us is this a validated user or not, that might get wiped out. Any information stored in the session might get wiped out, wiped blank. But there's a difference between taking a session and wiping all of the information out of it, but leaving the session, and destroying the session entirely. This is talking about destroying the session entirely, but often, like, you don't need to destroy it if you just take your big eraser and you go, right? Does that make sense? So, authorization levels. This is what I was talking about before. So, when a user is logged in, we also need to record their access level. Or we need, access level for a user is generally something that will be stored in the database, right? The user does not grant themselves an access level. Ordinarily, like the way that things work here at Mohawk, is when a user is granted an access level, when a new user is created inside of Mohawk's system, right? A couple of additional pieces of information must be provided. Is this person a student? Is this person staff? Is this person faculty? Right? If you are a student, that means that the default access level you have to something like Canvas is the student access level and not the administrator or teacher access level, right? So your access level will be an entry alongside your entry in the database. This is an example of access levels for, I believe, a something like GitLab or something. So in this case, you can see that this looks like this is managed by Microsoft Access actually. So you have various different roles within an organization: administrator, editor, writer, author, contributor, premium customer, subscriber, and guest, right? Guests don't even have the ability to be authorized for anything but reading articles. Subscribers, premium customers, and contributors all only have read permission for articles. Authors can publish, edit, delete their own, and edit their own posts. Writers have delete any permissions above an author. Editors have all the same permissions as writers, and administrators can also preview anything. Administrators typically have default access to everything, right? Administrator is normally the highest level of permission you will have in any of these sorts of access level organizations. So essentially, once you have data like this, you need some kind of representation of this inside of PHP if you are going to apply this programmatically. So this is a two-dimensional array of booleans, right? The way that PHP would represent something like this is using an access control list. So we set up the access control list as an array. We specify various levels of permission. For example, in this case, just admin and user. And we say, I actually don't quite like this example because these are functions, but they have the same name as the persons. But basically, both administrators and users have access to home and user permissions, but only the administrator has access to administration permissions. For what that actually means in terms of your ability to do stuff, that depends greatly on what the website is. So you would access this, for example, user admin false indicates that a user has no administrative privilege on the website, which is probably what you want. Make sense? Sound good? Any questions? So, yes, we've talked about that sort of thing. So, we've already talked about passwords to a certain extent, but they are, of course, a notoriously tricky problem. If a database is hacked and the passwords are stored in plain text, the attacker can see them, which is a problem. People often reuse passwords across multiple websites. How many people do that? Yeah, pretty much everybody. And nobody should, but everybody does, right? So, if a website that stores your password in plain text is breached, then whoever sees your password for that site also sees your password for a bunch of other different sites. So really, you should just never repeat your passwords in general. But if you are going to repeat your passwords, you should probably do so on extremely high quality websites, which, of course is not the way that people are inclined. It's like, oh, this stupid thing wants me to make an account now, I'll just give it the default password, right? It's like, I'm only going to use this once, right? Well, that's exactly the type of smaller to smallish website that would get hacked in the first place. So you've just given your password you use for everything to the people most likely to breach it. So, passwords are tricky. So it's our responsibility as people who program servers to not store our users' passwords in plain text. Even aside from the idea of breach from the outside of your organization, this can be a problem from within the organization as well. You might be a person who has to work on a team with hundreds of people. Is every single person on your team trustworthy? Right? Do some of the people on your team have a side business selling information or causing havoc? Who knows? in any large enough organization, it's likely that you'll have a few, right? So, if your users' passwords are stored in plain text, people with access to the database can view them, and your own, like the people within your organization may not be trustworthy at that extent, to that extent. So nobody should be able to see the password, including you, basically. So this is why we hash passwords. So we use a scheme for passwords called salting and hashing. This is the modern approach to password management. So, salting and hashing. So, let's go on a journey. Let's go on a journey of password safety, shall we? So, the first step in our journey is having passwords at all, right? Having passwords is much better than not having passwords. So, the first step in our journey is plain text. Plain text is a problem for all of the reasons previously stated, right? Anybody within the organization could steal the password. If the database is breached, there go all your passwords. We shouldn't do plain text. So, the question then, how do we change a plain text password to make it more secure? Well, anytime we want to hide any information on the internet, what do we do? What do we do to packets before we send them to the server and back again? Encryption. Very good. So, do you folks know how encryption works?
We talked about it in networking.
You talked about it in networking, but do you have a conceptual understanding?
I feel like I did last semester, but I also tried to get rid of all of the information I got from networking because it's so bad.
Well, let's see if we can't retrieve some of the important stuff then. So, encryption is extremely important. It is a process by which you take information, you pass it into, I'm going to do it as a big arrow like this. No, I'm going to do it slightly differently. So, when you encrypt data, you take information, you pass it through a pseudo-random algorithm that scrambles the data. It scrambles the data in such a way that it's not impossible to reconstruct the data, just exceedingly difficult. This comes back again to our conception of computer security, just like any other security. All security is just a series of deterrents, right? The lock on your house isn't going to stop a burglar who has a crowbar, right? You know, a couple of sliding deadbolts to hold your door in place might resist a crowbar for a period of time, but not if they're sufficiently determined, and not if they decide to go in the window instead, right? All security is like this. All security is a series of deterrents. There's no such thing as absolute security, right? Even if you were to take your information and send it to Mars, all that would require is that somebody else send a person to Mars to go get your information, right? So, encryption can be broken, it's just it's just very difficult. Encryption works by having an encryption key. So if you have this secret number, you encrypt the information in a particular way. It's like the seed of the random number generator. You guys know what a seed value is for random number generation? How much do you know about random number generation? Okay, who's played Minecraft? Okay, so how many people have played around with the new world dialogue? Like when you create a new world, you know, right? What's one of the values that you can set for the new world that you're creating?
Like, do you mean like what's it called? Like there's a bar that you can type in like any number and it'll like create a world based off of that number?
That's right. That's precisely what I'm talking about. That's the seed value, right? So computers are not capable of true randomness. Human beings are capable of true randomness because, you know, I don't know, wibbly wobbly, subatomic physicsy, you know, quantum mechanics is actually like based on probabilities rather than Newtonian physics. Whatever! Doesn't matter. We seem to have the ability to do random stuff. Human beings are always doing random stuff, right? Computers don't have that ability. Computers are purely logical and deterministic. To create a number, the machine requires a number, right? When you enter a number in on your Minecraft seed value, right? The purpose of making that part of the dialogue is if you want to regenerate the same world, you can enter the same seed value and you can get the same world, right? Now they're taking that seed value and they're like modifying it as they go, but basically that's the number that your random number generation algorithm is starting with, right? The key in encryption functions very similarly, right? If I know this number, I can produce this from that, right? It's like I take this information, I put it in, so long as the key is the same, this will always be produced. Does that make sense? Consistently. If I were to provide a different key here, I would get different random output. If I were to change this back to the same key as before, I would get the same output as before. Right? Good. And another really important aspect of encryption algorithms is that if you take data which has been encrypted and you apply the key again, you can decrypt the information and retrieve back the same information that you had before, right? This is also a very, very important aspect of encryption. Encryption is reversible. Does that make sense? So this is why you can do things like encrypted payloads on HTTP packets. You guys have heard the term TLS handshake, right? What does the TLS handshake do?
It creates like a connection between the client and the server for data to securely be transferred.
Yes, and you know what it's actually doing to enable that? It's making sure that the client and the server have agreed on the same encryption key. If the client and the server agree on the encryption key, the client can encrypt data, send it to the server where it's decrypted back into the information, right? You can kind of think of like the internet being on this side, right? Then the server can take information, encrypt it according to this key, send it to the client decrypts it according to the same key, gets that information again. The client and the server have agreed on an encryption key. That's what enables internet communication to be, secure, more secure anyways. Now, interesting thing, right? If a man-in-the-middle attack occurs and manages to capture the TLS handshake, then the man in the middle gets the encryption key and can therefore decrypt, re-encrypt, and inject data into internet packets. And that's generally how you try to accomplish a man in the middle attack, is by capturing without this encryption key you can't really do anything, right? But if you have this, you can set yourself up in the middle, like catch the packet, pull it apart, stuff some bad stuff in, close it back up again, re-encrypt it, send it off. And you think it's secure, but it's not. Is it a perfect system? No. All security is a series of deterrents. Okay, so let's go back to how we are storing passwords. Right? Encrypted is better than plain text. But here's the problem. Single point of failure. Right? It's possible to reconstruct an encryption key if you have enough data that uses it, right? If somehow the key for the encryption process were to be disclosed, leaked, processed out, found out somehow, you have lost access to the entire database, right? Basically, with the encryption key, you are basically bopped back to the level of plain text, right? All that the attacker needs to do is decrypt the entire database, and they have everything back in plain text again. Does that make sense? So, okay, encryption is better than plain text, but we need something better than that. Okay? So, the next thing is hashing. So, hashing. So, hashing is one-way encryption. When we hash a password, we get a random number back out again, but there's no encryption key. We've removed the flaw, right? We can't go backwards. There's no way to unhash a value. This is an improvement, right? It's also the case of hashing that a couple of things will all hash to the same value, right? So you can't tell which one of these hashed and which ones didn't. So in practice, like this isn't an issue normally, like, but mathematically speaking, this is the case, and like it complexifies the problem. This is the reason that reverse hashing doesn't, like, there's no such thing as reverse hashing, because if we were to take this random number that was the result of a hash, which of these possible inputs was the one that we started off with? It's actually impossible to determine. So if you were to attempt to unhash a value, you would get a set of possible input information rather than the one exact piece of input information. And this has to do with the types of mathematical operations that hashes normally use. The modulus operator, for example, right? It's the modulus operator is used in hashing. It causes this effect, right? Like if you have, for example, 3 mod 10, 13 mod 10, and 43 mod 10, right? In every case, the value of that is 3, right? But if you took 3 and you tried to unmodulus it, right? There's a lot of different things that you could have started at. You don't actually know which one of those was the case, right? Yes?
How does the server use the hash information if they can't tell what it originally contained?
I'm so glad you asked that question. So, although you cannot restore the original information, the same information will hash to the same value each time. So it's repeatable, right? So, for example, if I had, say, hello, and I hash it, I might get something like 77372228, just using digits. It would include more characters than that, but let's just go with that for now. If I were to hash hello, if I were to hash goodbye, I would get 9383292 or something, right? But if I were then to turn around and hash hello again by the same algorithm, I would get 77372228. You can take this, you can take that, you can perform equality comparison on them. You can determine if these guys were the same, right, from just the hashes. Which means that this one can have happened in the past and you can have forgotten what this word was going in, right? If the same word is provided again, you do have a way of testing to see if it was the same word.
So it's only really used for, say, like, password encryption, because it wouldn't be used for, like, other data that you might need to interpret on the server side, just comparing if it was, like, yes, that's the right password because it was encrypted the same way.
Yeah, like you don't use hashing for like general data storage, and like if someone hashed your hard drive, you would need a new computer, right? Whereas if somebody encrypted your hard drive in a ransomware attack, they could, in theory, provide you the key, and you could have your computer decrypted, right? Yes. So hashing is good. We like hashing. Hashing solves the problem that encryption had, where basically if you have the key, you're in a plain text situation anyway. Now, hashing itself has problems, right? the algorithm itself becomes the vulnerability, right? These algorithms are generally well known. A good hash will run several hashes, like a good hashing algorithm runs many sub-hashes over, like you run like this one, now that one, now that one, now that one, right? All in sequence. But if I know, for example, there's a sort of older hashing algorithm called MD5. If I know what algorithm has been used to hash the values, right, then I can just try combinations until I hit the one that matches that one, and now I've reconstructed the original password, right? That makes sense? So, and this is the process that was demonstrated in that YouTube video that I asked you guys to watch, right? When that fellow from the University of Nottingham was running Hashcat, CUDA Hashcat, to reconstruct passwords from that file, that is precisely what he was doing, right? Make sense? So, here, we are at least in a situation where if you have a very good and secure hash value that you're hashing in, it will take a long time to find it. So if you have something like 32 random characters as your password, even if it's just plain hashing, that will still be good enough. That your password is reasonably secure. But if your password is something like password, then it takes a little bit more time, but you can reverse it as well, right? So that's what hashing is. The next rung on the ladder, the next innovation that happens, all right? And this is an observation on hashing itself. If I take a value like AAA, right? Say I'm hashing that. That becomes, 1, 2, 3, or some other, that's not very random, but you here, 7, 2, 3. There we go, that's a little more random. If I add anything to this string, it further scrambles this value. So if I say AAA underscore Pokemon, I'm going to hash to 938 or some other completely different random value, right? So the next step after hashing is using a magic word, right? If I've done this, right, then even if, first of all, you can make this pretty long and difficult to brute force, right? But let's say that the hacker has managed to reconstruct my password, right? That's not actually my password, and it won't get you into my account, right? But the problem with that is, all the hacker has to do is, crack, 2, 3, 4 passwords. Notice that all of them have the word underscore Pokemon put on the end of them. It's like, oh, all passwords have underscore Pokemon put on them by the server before they're sent to the database. That's easy enough to reconstruct. So with magic words, if you know the magic word, and it's not that difficult to reconstruct it, you're back to square one. So the current hot business in passwords is a process called salting. How do I like my potatoes? Hashed hashed and salted. So, a salt is a randomized string, which we are packing in here. So, with salt, it's like AAA underscore X37 exclamation point number sign AQ capital V. We generate a random sequence of characters. Every password gets its own unique magic word. This scrambles the hashes. You do have to store this thing in the database. So in theory, the things can be reconstructed, but you know, that's where we are right now, is the database, like the hashing and salting algorithm will provide a random magic word, which it then also stores inside of the hash value in some hopefully mysterious way. So that's a lot of information. Can these be cracked? Yes, absolutely. They can't be cracked as quickly though, and it makes even terrible passwords inherently unbrute forceable. So, you know, the question is then, like, can we start using terrible passwords? Is that okay? And the answer is, well, it's probably more acceptable than it used to be because of the existence of salting now, but you should still probably just have a secure password anyways, just from a security standpoint. So, in PHP, you have two functions, which are very important, which do all of this for you. One is password underscore hash, which takes a string and produces a hash from it. You then take that hash and you write it into the database. Take H and integrate that into your SQL query, right? Then, when you're retrieving information from your database, you use password verify, using the password that you started, that the user entered, and the hashed password from the database. So this would go in a registration script. This would go in a login script. Anytime you need to actually validate credentials, you don't use this thing, right? You don't use direct equality comparison. You use password verify, because that does all of the salting for you. Now, it requires that the passwords in the database be previously hashed, right? You have to set up both sides the same. And if you, you should always start off this way when you're creating a new system, because otherwise you'll have an existing database of people with passwords which have not hashed in this manner, and it's a pain in the arse to port them, particularly if they're not in plain text, because if the you can't reconstruct a new hash from an old hash, right? You can't, because you can't go backwards. You need the original passwords. So you know how every once in a while an organization will get you to update your password? That is an opportunity for that organization to introduce a new and more advanced hashing algorithm, because basically you maintain the database of the old logins, right? As soon as they log in, you force them to choose a new password. That new password gets put in to a new table in the database using a new and improved hashing algorithm, and you basically delete the entry in the old table. And over time, that that table of old credentials is basically reduced to the people who don't use your website anymore anyways, right? People, like if a person hasn't logged into your website for 2 years, they're probably not using your website anymore, right? With certain rare exceptions, like your bank shouldn't do that, but and I'm pretty sure that certain retailers got in trouble with some kind of scheme like that with respect to gift cards. Well, if you haven't used your gift card in 2 years, it's really our money anyway. So but yeah. Any questions about password hashing? Okay. Does that make sense? Hopefully that makes some sense. I know that's a little mathy, but yeah. It's still important to know, like honestly, like if you guys get a co-op or something, and you're like, first of all, if you were like a junior developer or a co-op person, they wouldn't task you with design of the database, right? That's not a junior dev thing to do. But presuming you did design a database and you designed it with a plain text password system, whoever your supervisor was would have every right to walk up to you and just slap you in the face, just like that. Just like that. Because there's really no excuse for having stored plain text passwords in an SQL server in current year. For the purposes of posterity, the current year is 2025. So yeah. Yes. So in PHP, the password that they have you determine, they have you determine a hashing algorithm as well. Again, it's very important that this not change once picked, unless you're doing something like an organization-wide password shift or something like that, right? Very good. Okay. So that's all I really have to say on the subject of credentialization. Again, a lot of that material we covered in the course of various in-class examples when we did our login system example. So I think now's as good a time as any for our break, since it's just about exactly the middle of the class once we factor in the 30 minutes. So let's have our 30-minute break. When we resume class, we will be in Laravel land, and we will be for the rest of the week. Sound good? Any questions, comments, concerns, philosophical questions? No? All right. In that case, please be ready to resume the learning at 2:15. Thank you. Now recording. So, in the first half, we downloaded the virtual machine and we unpacked it using VirtualBox. So that's where we're going to start off with, or that's where we're going to start off from. The process for unpacking one of these OVA files is File, Import Appliance. For next week, if you don't have one already, please get a portable hard drive, 1 terabyte of memory. If you unpack one of these things into an external drive, then you are saved the import-export process each time, which is convenient. And it also, the files are big enough that you can't just email them to yourself, right? The download is just under 6 gigs, and by the time you unpack it, it's more than that even, right? I recommend either Kingston or Western Digital as brands for the external drive. If you get it as an external drive, you can run it off the drive itself, If it's just a USB key, the USB key won't really be fast enough to support an operating system, right? Okay, so let's fire it up. Powering up VM. So while we're working on powering up the VMs, I'll give you a couple of hints and tips for using these things, particularly using Linux variants of these things. I'm not sure what your work setup looks like at your home workstations. It's extremely useful to have a second monitor. If you have a second monitor, you can set up the virtual machine on one monitor, have your regular operating system on the other monitor, and that's a very convenient way to work with it. While we're doing this, I'm going to click on the wrong taskbar probably at least 50 or 60 times. I'll keep a running tally for everybody how many times I click on the wrong interface. But is this working for anybody else?
Yeah, but I had a pop-up asking if I wanted to switch into a virtual box mode. You have a second virtual box window down there? I'm wondering if
Oh, I do.
you
Oh,
can-
there we go. That'll do it. Thank you. The virtual machine will now go into scale mode. Back when okay. So a very important hotkey when working with VMs in general is I don't have enough. Let's see here. This control key. This is like your access the VM button. Okay? So yes. Switch. There we go. The VM will of course capture your Linux Mint. Yay. Okay. All right, Kevin, did you change the password? Password should be Laravel. Let's see. There we go. Good. So the password to get into the VM is lowercase L-A-R-A-V-E-L. Laravel. Very good. So this is Linux Mint. This is the new business, the new niceness in the previous version of this was an Ubuntu image, and now it's a Mint image, and that just makes me a little happy because I happen to be a Mint user myself. So this is Linux Mint. In terms of how it works, it will feel very similar to Windows XP. That's kind of like what the Cinnamon desktop environment is based on. You see, you click here, you've got all of your programs in various categories, quick links, logout, etc. Within a VM, turn off means shut down the VM software process. You will see a couple of options. Home. Yeah. You'll see that if you hit right control home, that brings up the context menu for the VM itself. So under machine, you'll see that there are pause, reset, and ACPI shutdown. You should think of these commands as being equivalent to walking up to the computer and holding down the power button, or pulling the power cable out of the back of the machine. There is no hardware to screw up that way, and generally hardware doesn't screw up that way anymore. But neither are you allowing the operating system to gracefully turn itself off, right? So despite the fact that the VM has the option to shut down from the VM itself, unless the thing is frozen, you should shut it down from the shut off dialog inside of the operating system itself. It's the same thing as turning off your computer, like doing a hard reset, right? You want to avoid hard resets if possible. Make sense? So far so good? It's also possible to change, well, not the picture. If you type display, bring up the display program, it is entirely possible that the resolution of the VM is different from the monitor that you have attached to your computer. So this is a manual configuration step which is usually useful. Let's see here. There you go. In my case, I think we have the same size monitor. 16 by 9 is seems to be working pretty okay for me. So there you go. Make sense? So far so good? Any questions? Good. So let's find the Laravel installation directory. So, first things first, let's create a new Laravel app. This is going to require just a little bit of command line. So, let me just try to make sure that we're on the right page. Yeah. So one thing that you'll notice about VMs is like copy, paste, to and from doesn't quite work. There's a way of tunneling that, but it's kind of a little tricky. So here it is. It's composer space create dash project, Laravel / Laravel. And then you give it a name, like hello, or whatever, hello world. There we go. So, does everybody have the VM open? Okay. So your, this guy right here is terminal, all right? You can open the terminal by clicking on it. It's also bound to Control-Alt-T, brings up terminal as well, which is handy. So, Composer. Well, we should be in the directory we want to be in first. So, within your home directory, let's make a new folder for Laravel projects. Laravel -projects. This is Linux, so please avoid spaces in any file name or folder name, okay? Enter that folder, right-click, open in terminal. You will notice that the current folder then becomes Laravel projects. Very good. Now, we want to enter that command. Composer, create -project, Laravel / Laravel, hello -world. There we go. And now it's downloading and extracting and downloading and extracting and generating and doing stuff, and you don't have to know the details, it's just doing the stuff. Has everybody got it doing the stuff? Cool. And it looks like we're finished. We now have a Hello World folder. Ta-da! If you prefer the GUI view, I don't know why you would, but there you have it. We have the Hello World folder right there. Look good? Now, uh-oh, that's a lot of stuff. So, all of this is Laravel stuff, right? This is the Laravel application. Over the course of the next few classes, we're going to be going over some of the bare bones, get something functional type material. But Laravel is a pretty deep subject. We have nowhere near enough time for a full treatment of it during this course. But some of the important stuff, just right off the top of the bat, right off the bat, where's my sword? Did I put that in my briefcase? Yes, I did. Why would I put it back in my briefcase? There we are. So, some important stuff. Routes or routes. This is part of the controller in MVC architecture. Resources. That's where you put things like your HTML files, JavaScript files, image files, CSS files in resources. Database is how you, do database stuff. A lot of this other stuff you don't really have to worry about at our level. Okay? So far so good? So, you may be wondering, it may be on the top of your mind, what is all this about then? Why are we doing this? Why is it called Laravel? What does this have to do with the rest of the course? Well, I hate to break it to you, cats and kittens, but hardly anybody uses vanilla PHP for anything anymore, right? Vanilla PHP is like, it just doesn't do enough for you. You have to do a lot of stuff manually. You have to set up a lot of patterns. You have a lot of places inside of a PHP script, because you're doing so much manually, where bugs can just get, they can get in. Anytime you're typing anything by hand, that's where bugs can get in, right? So essentially, and this is a trend that has been a trend for some time. We don't generally program in default PHP, we generally use a framework. Even if we're using a more up-to-date, modern server programming language, such as Node.js, there are also frameworks for Node.js. So what is a framework? It's just taking the boilerplate code and giving you stuff that does that for free. It's possible to create an app with equivalent functionality in a fraction of the time if you are using a framework versus if you are trying to program the whole thing yourself in PHP. Disadvantage, you must learn how the framework works, right? It requires specialized knowledge to use a framework, but once you know how it works, you can get a lot of work done very quickly, and they tend to have pretty high base stats and like look nice by default and all kinds of stuff like that, right? It depends on like the framework. Some of them do more for you, some of them do less for you, but yeah. So for the sorts of things that frameworks will do for you. Implementing MVC architecture or design patterns. You may have noticed that was a bit of a pain in default PHP. Well, here it's still a pain, but less of a pain. Frameworks implementing user authentication. That's useful, right? If you screw that code up, that can cause a lot of problems. It would be good to not have the opportunity to screw that code up, right? Frameworks come with configuration files. We just fill in our credentials, configure the server in the ways that we want it configured, etc. Some examples of PHP frameworks are Cake PHP, CodeIgniter, Symfony, and Laravel. Basically, for every server-side language, there are at least a dozen or two like actively maintained framework projects, but there will generally be like one or two really big popular frameworks for any particular language. PHP frameworks themselves can typically be extended with additional libraries and packages. The libraries will provide additional functionality on top of the framework. So this is sort of the advantage of having an active developer community. When developers work with frameworks, they say things like, ooh, wouldn't it be nice if it did this for me? And then they write a little piece of code that says, here, this thing does this for me. They put it up on GitHub. And then the people who maintain the framework are like, oh, well, can't include that for this reason, that, and the other. But, that's a good little add-on. We could make that into an add-on. PHP frameworks can but by the way, PHP isn't the only language with frameworks. Pretty much every language has a framework. Like I said, every language has at least a dozen or two. Very popular Python frameworks are Django and Flask. Node.js has a popular framework called Express, which I'm currently in the process of developing a course that uses it. Let me think. There's a Java one as well. I forget what the name is. So the point of a framework is that you're not reinventing the wheel, and this means that projects go much, much, much faster. Database configuration files are going to look virtually the same in every app, so why write it again every time, right? If you're trying to solve a common task, such as authenticating a user, right? Why spend the time implementing it yourself when you can get the thing to do it for you, right? Set some parameters, go. A lot of this is, this stuff is generally called, boilerplate code. Another example of boilerplate code, you know all of that Emmet abbreviation stuff that VS Code dumps into an HTML file for you, right? Can you imagine how much slower things would go if you had to type that out correctly each time? Right? This is kind of the idea, right? PHP frameworks can potentially make the app more secure, unless you have the resources to implement all the security features. So this kind of hinges on, there are people who are smarter, more experienced, and have more security experience than you who are working on the framework. Therefore, your skill at securing an application is going to be less than their skill. There will be, cases they consider which you don't, forms of attack that they consider which you don't. In general, the best security advice for a developer is to use a good recent version of whatever language or framework you're using and look up a guide as to how to use the security functions built in. You should not be implementing your own security features as a general rule. Make sense? So, communities around PHP frameworks are very powerful in and of themselves. I noted this already, but the developer community will work on code and then submit that code to the project, which is extremely valuable to everyone involved. This is generally why you have this kind of property in software projects where the project will be written by some person for a number of years. Slowly people will sort of see it, think it's cool, and join up, and once it reaches a certain size and if it can attract the patronage of a major software company like Google or Microsoft, that helps tremendously. But and that's generally what's going on at conferences, right? When you have a software conference and you have some guy stand up on the stage explaining a new framework that he's developed for this, that, or the other. The point of that is that there are people from Microsoft or Google or any of these other big software houses at that conference listening to the presentation saying, you know what? I like the cut of your jib. I like that project. Maybe we could work together. Normally this means that the person continues to work on this project, but as an employee of whatever big software house. And of course the big software house ends up owning the rights and stuff like that. But a lot of these projects will continue as open source projects, even if ultimately they're backed by Microsoft, who's generally not hugely in favor of the open source movement. Because in general, proprietary software is dead or dying as a general thing. I think I'm comfortable making that statement. Like, there are still like big holdouts, right? Again, Microsoft being one of them, but in general, I don't think I've seen a new proprietary compiler released like in the last 15 or 20 years. You know, it's all open source, right? So you guys know what open source even means?
Free to the public?
Well, a little bit. It's a little bit more than just free, because a lot of software is free, but you can distribute a pre-compiled binary of free software, and it doesn't make it open source. Open source software also doesn't necessarily mean free. You can have paid open source software where a good example of this is there's this little program that I love. It's called Sprite. It is an animated. It's a tool for animating pixel art. It's very cool. It's open source. The project is on GitHub. Basically, what the company charges for is the pre-compiled binaries, and I tried compiling this stupid thing on Linux, and let me tell you, that is worth money. Getting someone to get it to compile for you. So yeah, open source doesn't necessarily mean free. The acronym which is generally thrown around these days is FOSS, which is free and open source software. So open source means you can go look at the code somewhere. And the code, the code is not under copyright, basically. So with an open source software project, there will be something like a GitHub repository that you can go get the code, download their code, modify it yourself, re-upload it, use it for yourself. Generally speaking, there are a couple of provisos, intellectual property provisos that apply to open source projects. They kind of, it's slightly tongue-in-cheek, but they call it copyleft rather than copyright. So a good example of this is the Creative Commons license. Although there are, the GNU licenses, is also a good example. So basically, as part of the licensing for open source projects, they can specify things like credit must be given to the original creator. Fair enough. Only non-commercial uses of the work are permitted. You can leave that clause in or out, right? Adaptations must be shared under the same terms. So you can see that that's much more, that's much freer than copyright, right? Which is this is my code and you can't use it, right? The MIT version 3 license, the GNU license, and the Creative Commons license have kind of collectively brought into existence the open source software movement, where code isn't necessarily owned by a company and locked away behind lock and key, and nobody can ever use this code. It's just us, just for us. This is generally the way things worked in the 60s, 70s, 80s, and even the 90s. But as the internet has allowed the free distribution of information, it has also permitted the free distribution of software. And this is partially a reaction to the fact that preventing people from taking source code is almost impossible anyways, right? But anyway, so basically what this does is it fosters a spirit of collaboration. Like Linux is a copyleft operating system, right? It operates under the same principles. And while it's true that like big software and hardware houses like IBM and Google and all of these people, they will have people on payroll, on staff, whose like sole purpose is to contribute to these open source projects. But it's because those companies use and find useful the projects. Like a good example of this is the Debian operating system, right? Debian has a heck of a lot of security work put into it by expert security people who are employed by the big software houses, right? But it's extremely useful to have the base image of Debian be extremely secure because, like, it's the base distro for like 70% of the Linux operating systems out there, probably including Android, and one of the big competitors to it is Red Hat or Red Hat Enterprise Linux, which is like the same story, but it sort of derives differently, but it's very similar in that it's funded by a lot of companies that like put people on the task, right? But this type of licensing means that your like general enthusiast can also contribute code, right? But anyway, enough on that subject. But this is how things like Laravel get built up, is by like a couple of core people and enthusiasts providing contributions. So this is a listing of PHP frameworks. The data is somewhat old, but this is a listing of PHP frameworks on GitHub according to how popular they are on GitHub. GitHub has a rating, like a star rating for like how many times a person likes a project, right? It's like likes, it's just likes, it's what they call them, stars. And this guy right here, purple, you can see that is Laravel. So you can see around 2013, Laravel starts taking off, overtakes this guy, which was Symfony. Symfony is still like quite popular, relatively speaking. The other one is CodeIgniter. Basically, because this is number of likes, what you're really interested in is the rate of change of the graph, right? Because that means how much new interest is this thing attracting every month, right? But yeah, so the reason we're studying Laravel is because it's far and away the most popular PHP framework. I've heard people say that Laravel is the only thing keeping PHP alive. And to that I say, no. WordPress and Laravel are the only things keeping PHP alive. So this is PHP framework popularity at work from SitePoint to the 2015 survey. You can see Laravel, again, the most popular PHP framework. So Laravel is what you might call a heavyweight framework. You saw that it did quite a bit to install itself, right? It has the strongest community. It supports MVC architecture, and it is suitable for large-scale applications. Laravel used to be more difficult to install and learn, but it has improved a lot over the years. a lot of the time, like, because ultimately the purpose of the framework is ease of use, like, ease of use improvements are something you typically see in frameworks. So it's always worth it to update to the latest version. Also, it's always worth it to update to the latest version because of security. So, Laravel, there's the logo. Some of Laravel's features, again, MVC architecture. Sophisticated routing system, we will be talking about routing within, actually immediately once we're done talking about this. Active record pattern makes accessing databases easier. Only PHP code is needed. Blade templates, a powerful template engine for creating views. So, one thing that's important to know about Laravel, it is a PHP framework, which means that everything Laravel does, well, let me back that sentence up. If you want to implement something in Laravel and you are unsure about how to do so, first you should look up how to do it properly. But if you can't figure it out even then, you always have PHP to fall back on, right? Because PHP is the underlying language, you can use your PHP skills to get stuff done in Laravel as well. It's not a completely new language. Does that make sense? Any questions? So far, so good? We will skip talking about installation. We've already got that working. Yes, okay. No, we're not going to install it using Docker. Although, if you want to install it natively on your own computer, Docker would be one way to do it. There are slides on this if you want to take a look through them, but I'm not going to go through them in class because we have a lot to get through. So, a little bit about Laravel's directory structure. First, your app directory is where most application logic will be placed, including controllers. Your configuration files will go in the config folder. Your database migration and seed files will go in database. Resources contains all of your view files, including JavaScript, CSS, and your templates, your Blade templates. Routes, the file that defines how routing will work. Make sense? Not yet, but it will, hopefully. So,
Can I ask a question that's not related to Laravel? You say that PHP is going extinct. What is the most common backend language to use?
I could tell you, but I'm going to show you a graph. So, is this, can I run that up a little bit? There we go. So, you remember me talking about how I'm writing this course for Node.js? Web frameworks and technology. So this is the 2024 Stack Overflow Developer Survey. So, you know, you guys have seen Stack Overflow, I presume, at this point. The guys on there know something, right? This is a survey of contributors on Stack Overflow. You can even like filter by professional developers. So you may look at this and you may say, well, I can see that like Node.js and React are like right at the top too, and depending on how you look, depending on how like who you include in the response, you either have like React being at like 39% or like to 41.6%. You might be saying, okay, so why did I go for Node over React, right? Why would I say Node? Well, this is a front-end framework, right? Front-end framework, back-end framework, right? Front-end framework, front-end framework, front-end framework, back-end framework. You remember how I was saying Express, like Node.js has the Express framework? So these guys go together like peanut butter and jam. That's actually the same system, those two. Angular, I forget what Angular is, but like if you're looking for like the next most popular backend framework, I'm not sure about Angular, but it might be like ASP.NET, I believe, is a backend framework. Not sure what the difference there is. Flask is the Python one that I was talking about. Django, not sure what Spring Boot is. But you can see that Node.js is like, it's beating out the next most popular backend framework by a factor of 2 at least, right? So yeah, so that's what the current hotness is in backend frameworks. Node.js is a JavaScript framework, so it's a way of running JavaScript on the back end. Basically, it's using the V8 JavaScript engine that Google has put together for Google Chrome, which is exceptionally good. It's like, like JavaScript, Node.js is like the ultimate exercise in making a silk purse out of a sow's ear. Because like JavaScript itself as a language is horrible, but like with enough effort on the part of Google, they have taken a horrible language and made a semi-decent language out of it, and one that's actually suitable for an application on a server, which is kind of incredible. But it's a very interesting language, and that's what the new hotness is. You'll notice that PHP is like, you know, where is Laravel on this list? That's a good question. Well, you remember I did say WordPress, right? WordPress. I believe that's a front-end framework. I could be wrong. I think that's a front-end framework. Or at least it's front-end, back-end. Here you go. Laravel. Right? And if we were to take a look at another good one here is just programming languages, right? JavaScript, HTML, CSS, Python, SQL, TypeScript, Bash, Java, C#, C++, C, and poor little PHP, one above PowerShell. Do you know what PowerShell is?
Is that just like terminal coding?
Yeah, it's like Bash, but for Windows. Poor Windows. But yeah, and you know, things go down from there. COBOL at 0.7%. Wow, Prolog is more popular than COBOL. That's amazing. Okay, so that's what the current landscape looks like. Thank you very much for the question. I think that it might be true that that God put me in this faculty to get us off of the LAMP stack and onto the MERN stack, but you know, MERN is Mongo, Express, React, and Node. And that's kind of like, that's the new hotness in terms of development languages. But, you know, they're gonna have to shell out for some dev time if they want their courses updated. So, including this one needs to be updated too. That's okay. It's kind of a thing with courses that they always need to be updated at all times, you know? So, let's see here, where were we? Like, where did my link go? I had a slide. Where are my slides? Where are my slides? Maybe I didn't. Maybe I was between slides. Okay. Whew. Okay. So. So, in order to do anything at all with Laravel, the very first thing that we need to learn is how to accept packets, right? This is a very, very important thing for a server. We need to know how to receive packets from a client, right? Now, in PHP, this is a problem that is handled primarily by the file system of the server itself, right? We kind of think, oh, you know, if we want to access, you know, something particular with PHP, we access the script associated with that function, right? This kind of classic PHP, not like MVC architecture, but like the classic PHP approach would be you would have a login script, you would have a logout script, you would have a registration script, you would have all of these scripts that were kind of like representing individual operations, right? That is something we need to collect up in our arms, walk it over to the trash bin, and stuff that idea down into the trash bin, okay? You have to think of Laravel holistically as a server, all right? We are not running individual scripts in Laravel. We are designing a server to respond to various types of packets in various ways. The way that we write Laravel programs to respond to packets is using routing. Remember we had a routes folder, right? So, routing is how Laravel decides what function should execute in response to URL paths that have been requested. So, first things first, let us dissect a URL. All right? We will take it, we will dissect it, we will find the constituent points. So, I will turn the volume down so I don't get copy striked. YouTube.com. Rickroll, my favorite. There we go. Pause, there we go. So let's take that URL. Blow it up. There we go. I'm going to add one more thing here. There we go. So, behold, a URL. anybody tell me what this portion of the URL is called? Or what's its function?
Is it like the, how do I say? It's meant for Google, or like, it's like, it's what puts the like link, I don't know how to explain it. Like all URLs have that at the, like when you double click, but I forgot like how to explain it.
It depends. It depends. It's possible to have variants on this, such as FTP and SSH. You are right that like every URL you've seen in a web browser starts with HTTPS, right? Do we know what HTTPS stands for? This you surely should have learned in networking. You're Googling it, aren't you?
Like, it's the extra S, the added security, if I recall. I do forget what the HTTP actually stands for. That's
Hypertext Transfer Protocol. Hypertext Transfer Protocol Secure. File Transfer Protocol Secure Shell. This is the packet format. Right? You guys remember packets from networking? You remember that there are different configurations for a packet? Right? You specify the configuration for the packet as that portion of the URL. Right? So, this is your protocol or packet type. All right, now, next. What's this thing called? We're dissecting a URL to find the root. Route. I'm going to pronounce it as both route and root, so yeah. What's this called? Hmm?
A link?
Did you say a link?
Yeah.
Well, the whole thing is a
Yeah,
link,
it's a link, yeah.
right? So if you were to enter something like www.google.ca, what do you get?
Like it's like a .cam, .com is like US.
Yeah, well, yes. I think .com actually stands for .company. Yeah, .ca is for Canadian domain space. But, I just used the word.
Domain?
Domain, yes. That's a domain. You guys know DNS, domain resolution? That's what, during domain resolution, using the DNS system, IP addresses, like you look up a domain, you get an IP address, right? That's what it means to register a domain, right? So, that's the domain. Alright? Now, what's this thing? I'll just tell you. That's the root. And these are query parameters, which can be decomposed. Or if we add some strategic spaces, we can see that that actually does look like a series of variable assignments, right? But the thing that we are interested in is the root, or route. Everything between the domain and the query parameters if they exist, right? We need to know the root. Now, they can get complicated. Let's take a look, for instance, at this one, which is on Canvas. First of all, what's this bit called? Review of the thing we just did? Protocol? What's this thing called? Domain? What's this thing called? The route. That's right. And the rest are the query parameters. So, let's take a look at this route. On a PHP server, we are used to the idea that each one of these indicates a subfolder on the machine, right? If we think about our htdocs inside of our XAMPP installation, to get something like that, we would have to make a folder courses, then a folder that number, then a folder files, and then a folder that number, and they'd all have to be nested, and then, and only then, in that final folder could we put index.php or whatever it was, right? Let me ask you a question. Do you think that on Canvas there is a folder called 22,095,895? Do you think there's a folder with that name? Probably not, right? What does that look like?
An ID.
It's an ID. So, the old internet classic way of thinking about a route is that this has a direct correspondence to folders. Folders in a file system somewhere. That's why the separator is the slash, the / for folders. That means folders in Unix, right? We now abstract ourselves one layer. We no longer think of this as a folder structure. We think of this in the following way. Get the idea? So, using modern routing, we can accept parameters in the URL itself. And this is commonly done. You'll find many, many websites that do this now. And in fact, if we go back to our good friend Mr. Astley, copy video URL at current time. Let's see if there's anything about that link that we noticed. Note, no question mark, right? No question mark, meaning we are not sending regular get parameters. The root is the video's ID number. I believe it also works if you do YouTube/watch/that number. But you know, perhaps I'm whipping a dead horse. Does this make sense? Hopefully, just a little bit, even just a little bit of sense is progress. So, when we write a Laravel program, when we design a Laravel server, we use, like, what we are essentially trying to do, we are writing routing rules rather than writing a bunch of PHP scripts that are supposed to interact in some sort of fashion. Make sense? We are writing rules to capture routes. Okay? So, within the routes folder, we have a couple of files. The one that we're going to be concerned about in this class is web.php. This is for defining web interfaces. API.php is for defining stateless routing. REST applications would use API.php. For our purposes, we're not getting into REST APIs, we just want to write a web server. So web.php is what we're looking for. So let's find the file, shall we? Within your Linux Mint things, remember the password is Laravel. Within our project folder, which we created, we have the routes folder. You'll see that we have web and console. So API, I guess you would have to configure something to get it. But let's take a look. Oh, yeah, don't open it with LibreOffice Reader. Oof. What do we have here for code editors? Visual Studio Code. That will do. VS Code. Although it's not in dark mode, Kevin. My goodness. Kevin, you should be ashamed of yourself. You should be ashamed. Hang your head in shame for not using dark mode. That's mighty, mighty big talk from a guy who didn't even make the VM, right? Open file, Laravel projects, hello world, routes, web.php. So, don't worry about the import statement. Route, get, / function, return, view, welcome. Okay. So let's dissect this, shall we? Route, get. So you can see that up here, we are using Illuminate Support Facades route. So we are importing the routing library. This thing is a scope resolution operator, although it has another name which I can't pronounce and is Hebrew in the PHP documentation. I also can't remember it as well as not being able to pronounce it. Just think of it as the scope resolution operator. So basically, from route, we are pulling out a function called get. Now, can anybody guess why get? Why does it say get?
It's the method method for sending the data?
Receive, it's the method
Receiving.
receiving, yeah. So this is responding to incoming GET requests. Alright? You also have things like route, post, and route any. Make sense? Any will respond, as you might imagine, to any method type. Sound good? Make sense? Okay. Pick method type. Now let's examine this guy. This is the routing string. So you'll notice a lot of the time when you have a URL such as www.google.ca/, the slash is often like added, even if you didn't type it in. If you look at the URL, the slash is in there, right? So a route just as a plain slash generally means like home or root directory, or I don't want to specify a route actually, so here's nothing, right? It's the nothing route, the route to nothing. So routing uses a software pattern called pattern matching, right? So basically, if you have a bunch of statements like this, it will go through them in order. It will see if the route that's been requested matches the routing string. If it does, it goes with that function. And if it doesn't, it goes on and tries the next one. And if it doesn't match any of them, then you get something like a 404 response, right? So we can do something a little crazy. Route get /hello function. You'll notice this is a function in kind of a JavaScript-y kind of sense, eh? Return hello world. This will work, but we will have to turn the server on first. So, everybody got that down? So let's go back to our command line interface. If we change directory into the directory that contains the project folders, cd hello-world. By the way, if you're in a command line environment and you want to, you can auto-complete file and folder names using tab, which is very handy. Also, you can go up and down through your history of commands by using the up and down arrows. And if you want to see the entire history of your commands, just type history, and it will tell you all of the commands that have been used, including a bunch that Kevin did. Hee hee hee. Haha, Kevin, you didn't delete your bash history before you distributed this VM. And he's like, well, I didn't really do anything important in it anyway, so. Anyway, so, the command to start the server is PHP artisan serve. If this is executed from the project directory in the bash shell, you can see info, server running on http://127.0.0.1 port 8000. So this is an important number because that corresponds to localhost. So if we grab a browser, and it must be inside the VM, this browser, such as Firefox, we go to localhost :8000. There we go. There is the Laravel splash page. Taking a look at our, taking a look here, because we entered it without entering a route, that's the result of this rule. Return view welcome. That's what the return view welcome gives you, is the Laravel splash page. Normally you remove that and replace it with your own splash page, right? At least in any professional project, you'll probably have a home page. So here's an interesting thing though. Oh man, there we go. If we go back to the browser, let's say localhost/hello. Ta-da! We have our hello world. So, I'm gonna see if you guys got it working. Did you get it working? PHP space artisan SAN. Yes, just SAN space serve. Oh, you're not in the right. You're not in the right folder. So right now, so ls is a command that will show you like what's in the folder you're in. pwd shows you where you are absolutely. So you are in Laravel projects, not in the specific folder for that project. So cd change directory, and then you can just type tab. Now try space up, enter. Oh, and you got syntax errors, my friend. Unexpected edit file. Let me see. You might need a semicolon right there. Let me pull my code up and see if that's the case. Yeah. You just need a semicolon here. I know it looks like this is kind of like a kind of a JavaScript-esque way of doing things with the anonymous function. That's actually called a closure in PHP. But this kind of makes it look like it's a function, but this is actually a statement, so it still requires the semicolon. Did you get it working? And I presume you're distracted. Yeah. Good. So, congratulations. We have successfully hello worlded. This is good. This is fine. This is excellent. So first of all, in a lot of the documentation, they will call a URL a URI. I believe because like the L in URL stands for location, and we're not really talking about locations anymore. You know, for the reasons we went through, like we're now like using URLs to transmit like key value data and like ID numbers and that sort of things. And an ID value is not a location, right? So the term being used now is URI, but don't be fooled, it's just a URL. It's still the thing in the address bar. right? So the first argument is the URI, the pattern of the URI that we're trying to match. The second is the callback function, the callback method here. As we saw, we can define an anonymous function. Whatever the return value of this function is, that is what gets sent off to the client. Right? So if we take a look at the browser that has loaded this thing, hello world, inspect, you'll notice that if you look at the file itself, right, you actually have like the HTML tag, you have the body tag, and the head tag that's empty, and hello world has been dropped inside of the body, right? This is something that Firefox does when it receives plain text, is it will just wrap it in this stuff after having received it. We didn't send all of those HTML tags, but we could, right? The next thing that we need to learn how to do is to send an HTML page, right? Although, for the time being, let's play a little bit more with the routing to see if we can get that working a little bit. So, all right, everybody. I would like all of you, perform an exercise for me. Create a new routing rule for the route/fruit and respond with a sentence containing the name of your favorite fruit. Okay? Just to try to solidify it. Nice. Oh, you may have to stop and restart the server. When you did you stop and restart the server?
Nope, I just.
Oh, it's listening for that? Okay. That's cool. In Node you have to restart the server, which is a little annoying, but so it goes. Alright. So good. It seems everybody has got that underhand. Did you get it working? Awesome. Working? Good. So, now, let's learn how to take some parameters. This is a little bit more complicated, but that's okay. So, we can specify particular areas of the root to be variables by enclosing them in curly braces. So, for example, user ID. This extracts the value at this position in the root and passes it as an argument to the callback function. So, for example, let's say I had route get, nope. By the way, my recommended order for typing things, all right? First, this is a function, so open, close brace, put your semicolon in first, that way you won't forget it at the end. Then you can go in, put your routing string in, function, open, close, press enter, everything is the way you want it. So, let's say I had name, and I put in a parameter called, well, name, or maybe just n. I can then pass, that then gets passed to the function as the first argument. We can pick that up by giving it a name, and now we can use it inside of our routing information, or inside of our callback function, pardon me. We can say return hello n the weather has been miserable, which is true. It's been very typical March weather for the beginning of April. So, save that. Within the VM, go here. Name, Nick. Hello, Nick. The weather has been miserable. Ta-da! I will put the code back up. Is it working? In the URL, match this. So type name / and then put your name. Working? 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 Internal server error. Ooh. You know, you can use your own name. Let's see. Unexpected token. Got you twice.
It's nice that it actually shows you proper errors, unlike coding in PHP, knock it out.
Right? Okay, like, I know that it's like, Laravel is a lot to throw at you right at the end of the semester. It's like we're learning a whole new system, but like it is, there are improvements over PHP. As you note, PHP has terrible error messages where it has error messages at all. Yeah, so it's nice. I agree with you. I totally agree with you. So, like an actual syntax error by gum, you know? And if you actually, that might be actually kind of interesting. If I intentionally induce a syntax error, let's see what that actually looks like on here.
It's pretty accurate with how to fix it.
Yep. So, parse error, syntax error, unexpected curly brace, expecting semicolon, right? it shows you the point in the code where the error occurred. And you know, quick hint on programming, guys. Whenever it's complaining about a line that's seemingly innocuous, always look at the line before it, right? You know, it'll show you a stack frame. There's more information down here about like what the exact nature of the request was, right? Like if you have any query parameters, that should show up here as well. Yeah, like a lot of debug information, which is nice. And you can see, oh, here's an interesting thing as well, right? If you look back at the command line interface, all of the requests that the server is receiving are being logged. Like they're being logged in more detail than this, but you can get a quick view of like what has been requested from the server over time and how long the server took to process the requests. So that's also kind of interesting. By the way, how are the VMs running on the lab computers? Like, are they running well? No, like you're not noticing them being laggy or anything? Okay. Okay, so there is just enough time left in class for me to show you how to save your progress. Because basically you should like all of the stuff that you've done up to now will be destroyed, right? Unless you save this to some kind of medium. So here we go, all right? Closing the terminal also closes the server process. For now, and this is the worst way of doing it, but this is the way we're going to do it, right-click on your project folder, Hello World, right-click, compress. You probably want to make it a zip. Create. There you go. Boink. Hello World.zip. Open up the browser and email it to yourself. I know, I'm aware, it's the worst way to do it, but I'm out of options. This only is working because like this is functionally the only part of the operating system that we've modified, right? We haven't really done any important work anywhere else, so just email that to yourself, all right?
Google Drive is also a good option if you don't want to email it to yourself.
Google Drive, yep, sure. It probably won't accommodate like the size of the VM itself, though, I would imagine.
Probably
Yeah.
not though. Unless you can like pay to get more storage in it, but probably not just M-based. Although the storage isn't too bad. Like I use it for some things.
Yeah. Yeah, like you have more storage, but like the problem with cloud storage of VMs is that they're friggin' huge, and like you have to re-download them anyways, right? So like, what's the difference between re-downloading them from there or SharePoint? You know. So that being said, I'd like to show you one more thing. If you shut down the VM, again, shut it down from its own internal shutdown menu, please. If you go to VirtualBox, Laravel, right-click, export, there we go. Format, just open virtualization format. That will make the OVA file, right? Next, finish, there you go. It will start crunching that out. That's the way that you export the VM so that, like, once that OVA file is produced, you can think of this as like zipping up the operating system, right? If you're writing it to a USB stick and you want to like write it to the USB stick, take it with you, decompress it later, this is the way to do it. Again, the preferred way is to simply unpack the VM onto an external drive so you can just take the drive with you. Does that make sense?
To unpack the virtual machine on an external drive, would you have to have Oracle on the external drive already?
No, import appliance, file, there we go. Local files, yes, next. Oop, yes, fine, sure, shut up. Right here, next, there we go. Yes, come on. It might not do it because it's currently exporting. Export mode. Settings. Machine base folder is what you want. If you modify machine base folder so that it is targeting your own drive rather than the local operating system, that's where that setting is. And you should be able to relatively easily just unpack it to your external drive instead of here. Make sense? Any questions? You can see it takes a while, eh? I think I'm going to call class there. Any questions? All right. Well, in that case, I'll see you folks tomorrow. Again, I recommend picking up an external drive. Cool. They sell them at Canada Computers.